Okay. So, hi everyone. Very good evening and welcome back to Geeks for Geeks practice. Please give me a +1 in the chat, guys. If everything is working fine, you can hear me clearly and my video is visible as well. So, before starting, I'll quickly introduce myself. So, hi everyone. My name is Yash Dwivedi, and I'm currently working as a software engineer at Geeks for Geeks. Besides this, I have also been teaching DSA and competitive programming at Geeks for Geeks. And Ashish says that yes, everything is working fine. Very good. Karan Singh also says +1. Thanks a lot, everyone. So, without further ado, I'll just quickly share my screen so that we can start discussing this contest. Hi, Karan. Thank you that you know me. Okay. So, yeah, what I will do here is I'll just share my screen quickly and then we can start off. Okay. So yes, let's quickly open the GFG Weekly Contest. Let me check the audio part. Let's quickly open the GFG. Okay, everything is working fine. So yeah, please hit the like button as well, everyone, and then we'll be starting off. The contest is over. I guess the contest is 146 only, right? So yeah, let's open the problems one by one so that we can discuss all of them. These are the problems that were given. So yeah, minimum number of elements, then maximum valid sequences code, then geek task, and then valid pair of vertices. So let's do one thing. Let's open a whiteboard as well. You can give me you can tell me how many questions you were able to solve, guys, during the contest. Just quickly tell me how many questions you were able to solve. Hey, was there any post contest analysis for 145? I don't know about that because I did not take any such analysis. Okay. So yeah, everyone can can tell me. Everyone can tell me how many questions you were able to solve, guys, and make sure to hit the like button. And then I'm starting with the discussion now. Okay. So I have opened the first problem, that is minimum number of elements as well. If you want, I'll zoom it a bit more. Okay. So this was the problem. Everyone is ready. Let me know, and then we'll start off. Okay. 0, 1, 2. Okay. What about others? Others can also tell me. Please hit the like button if you haven't already. Yeah. So let us start with the discussion of the first problem, that is minimum number of elements. So let's write this name here. Minimum number of elements. Okay. Now second question, कैसे करना है बताओ कोई. Okay, we'll see that. So yeah, it says that you are given two integer arrays, right? So the problem says that you're given two integers array. You're given one integer array ARR1, okay, and then after that you're given another integer array, let's say ARR2. So these two arrays are given to us. After this, the problem says that so these two arrays are given to us. The first array has got n elements, okay. The first array has got n elements and the second array has got how many elements? M elements inside it. Now what you want to do is you have to find the minimum number of find the minimum number of elements that are needed to be chosen from the array, so that their sum is at least the sum of all the elements of the first array. If it is not possible, then you have to return -1, okay, and each element from the ARR2 can be selected only once. So basically what the question says, guys, is suppose that what you have been given the first array, okay. So what you have to do is from the first array, take the sum of all the elements of the first array, and then find what are the minimum number of elements inside the second array such that their sum is greater equal to the sum of the first array. Let's name it this as sum 1. So what you have to do is you have to take the minimum number of elements from the second array and add them up such that the sum is greater equal to the sum of the first array. So in this case, what I can do, can I say that if I have to use minimum number of elements, so firstly I'll take the sum of the first array. if you will see what will be the sum 1, the sum 1 will come out to be what, here if you see the first test case, so it will be 1 3 1 plus 3 plus 2, so that will be 6. So the sum will come out to be 6. Okay, sum 1 will come out to be 6. Then after this you see the second array. So the second array is what, the second array is consisting of 4 3 1 then 5 and then 2. So you have 4, then you have 3, then you have 1, okay, and then 5 and 2. So if you want the minimum number of elements, so which kind of elements you would like to take? You would like to take, you would like to take which kind of elements? You would like to take the higher elements first. Now if you take the larger elements first, then you will require minimum number of elements. So what you can do is you can sort the array, let's say in the ascending or descending order, whichever way you want to, and you can iterate from the higher elements first. So let's say I had 1 2 3, then I had 4, and then I had 5, right? So what I can do is if I go to this element, okay, 5, then in my sum 2 5 will be there. Okay, then after that if I go to this element, then in my sum 2 5 plus 4, so this will be 9. So you can see that the sum of these two elements like is greater than the sum of the first array completely. So then I can say that I'll require two elements. So that is how I can keep a count. Is that clear to everyone, guys? Please write yes or no. Is this part clear, how we are approaching this particular question? Are you all clear with the approach? Did you apply this approach only? You can sort it in any which order, but and then you have to tell how many elements you have taken, and that is how you can do it. And if this never happens, then you will return false. So you have to find the minimum number of elements so that the sum is at least the sum of all the elements of the first array, right? So yeah, people are saying that they have applied the same approach. So what I will do now is I'll try to, you can give me a +1, guys, if you have applied the same thing. Now what you can do is you can, let's say, take a sum 1 initially as 0, and you can also declare, let's say, int sum 2 initially as 0. Then what you can do is first of all you will take the sum of the first array. So you'll say that I starts from 0, I is less than n, then you will do I plus plus, and then what you will do is you will do sum 1 plus is equal to arr of I. So you'll take the sum arr 1 of I. So you will take the sum of the first array elements, right? Now after that what you will do is you will make your count initially as 0, and let's say you can sort the array, let's say in decreasing or in ascending or descending, whichever order. So suppose I will sort it in normal order, and I'll iterate from the back side. So what I will do is arr2 dot begin, I'll sort it, comma arr2 dot end. So I'll first of all sort this particular array, second array, and then after that I will iterate from the back, so from the larger elements. So I starts from m minus 1, then I is greater equal to 0, then I will do an I minus minus, and what I will do is I'll obviously count. So I'll mark the count as count plus plus, and then after this I will check that if the count is sorry, if then what I will do is after increasing the count, I'll say that sum 2 plus is equal to arr2 of I. So plus is equal to arr2 of I. So I'll add the element, and then after that I'll check that if the sum 2 is greater equal to sum 1 at any point of time, then I will break, because the moment the second array, from the second array I can generate at least sum as sum 1 or greater, then I will break away. Okay, and then after that at the end I will check that if the sum 2 was greater than equal to sum 1, then what I need to do is I need to return the count, that is the number of elements that I've taken, right? Else what I will do is, if it was not possible, then you can simply return -1. Clear, guys? Okay, let's try and quickly compile it and check if it is working fine or not. I hope this will be the logic for this question. Okay, refresh to submit. What are you saying? Okay, yeah, so you can see it is working fine on the samples. Let's try and submit this code to check if it is getting accepted or not. Yeah, it gets accepted. So yeah, is this problem clear to everyone, guys? What I have done here. So first of all, take the sum of the first array, then sort it in ascending order, let's say, and iterate from the higher elements. Increase the count, that is the number of elements that you are taking up, and then after that, if the sum is greater equal to n, then sum 2 is greater equal to n, then this means you have achieved your target, break. And if the sum was greater equal to the sum 1, then return the count of the elements, otherwise return -1, that it's not possible. So please write clear in the chat, guys. Yeah, you can do that also. Yeah, you could have done like the Shankar, what you are suggesting could have also been done. Okay, so let me just quickly generate the code link for this particular question. Okay, and then we'll proceed further. So I'll quickly open the ID and generate a link. Everyone can give me +1 and hit the like button, guys, if you all are clear with this problem. Then we can proceed further, right? So just give me a +1 in the chat, guys, if everything is working fine so far. Okay. Yeah, it was very easy, I will say. Agree with everyone. Okay. So yeah, I'll just share the link. You all can give me a quick +1, guys, if you were clear. I have shared the link of this problem, and can I see some energy? Can I see some likes in the chat? Sorry, can I see some likes? At the rate Ayush Srivastav. Okay. So second question. Okay, okay. I'll move forward to the second question, but can I get some? Can we get some likes on the video? Okay, so that YouTube can push this. Okay, so let's move on to the second question now. Okay, and let's try and solve this also. So I'll clean this up and I'll talk about this one. Okay, so how many of you were able to solve this question? You can tell me, right? So it says minimum valid subsequence score. So the name of this problem is minimum valid subsequence score. So minimum, then valid subsequence score. Okay, now what does this problem say? Uh, it says that you are given an integer array ARR of n integers. Okay, so basically it says that we are given an integer array. Let's name it as ARR. So we are given an integer array ARR of size n. Okay, ARR array has been given, and this array consists of n elements inside it. Okay, now since it has got n elements inside it, the sorry, yeah, maximum. Did I write minimum? Okay, sorry, yes, mistake. Maximum. Okay, in the previous problem it was asking for minimum, no? So that's why I got it got mixed. Yeah, so it says maximum valid subsequence code. So it says you are given what? You are given an integer array ARR of size n. So it consists of n elements. Okay, then a zero based index array. So you have to choose a subsequence of indices 0 to n minus 1 of length greater than 0. So it says that what you have to do is, if you are given an array, right? Suppose this is an array that is there. Okay, now can you tell me what is a subsequence, guys? Subsequence, it says that you can choose a subsequence, right? You can see here it says that you have to choose a subsequence of indices. So you have to choose a subsequence, means that you have to subsequence is what? Subarray is a contiguous segment of an array, right? Subarray is what? Like that you choose a contiguous segment of the array. If suppose that this was the left index, this was the right index of this particular subarray that I've chosen, then you will choose every element in that range. Okay, but in subsequence what happens? You can choose some elements and you can skip some elements, correct? Yes, subsequence is subset of array, but basically you have to take elements in order. Okay, suppose you can take suppose what you can do is, maybe you take this element, then after that you take this element, then you take this element, then you take this element. So like let's say this element was let's say x1, then this was x2, this was x3, this was x4, whatever, right? So you take this and this. So basically what you do is you take the elements in the order, from you take, like when you are at a particular element, so either you can choose a particular element in your subsequence or you can skip it, but what you have to do is you have to maintain the order of the element. So if suppose here you had 7, here you had 2, and there were several other elements, so if you choose this element and then this element, so you will say that the subsequence is 7 comma 2. Okay, clear, guys? That's in subsequence. Yeah, we don't break the order, so we maintain the left to right order in subsequence. Yeah, so this is what is the definition of a subsequence, guys. Now what does the question say further? Let's try and see. So it says that let this subsequence be b. So what you have to do is, you have been given an array and you have to choose a subsequence b from it. Okay, so you have to choose find the subsequence b of length, let's say le, and this subsequence is valid for all the I, such that in this particular subsequence what will happen is, so from this given array ARR, what will happen is, you will, from this given array ARR, you are choosing a subsequence b such that this condition is being followed. What is the condition? The condition is that whenever you take an array element, and from that element what you do is, if you from that element, if you do b of I minus 1, Okay, so it will be, if you take b of I minus 1 inside this array as an index, then what will happen is basically b array will be based on indexes only. So then this is going to be equal to arr of what, sorry, this is going to be equal to b of I minus b of I minus 1. So it says that what you what you can have is, if you choose any ith element from the b array, so the difference between the ith element and its previous element would be equal to the index of the b of I minus 1, uh, would be equal to ARR of b of I minus 1. This is the relation. I tried top down approach, TLE, without TLE. Yeah, I also did the same. Okay, so you can see here the score of subsequence B is equal to the summation of all the ARR of B of I. Okay, so what you have to do is you have to maximize your score. Okay, what is the score? Score is the sum of what is score here? So score is basically defined as the sum of all the ARR of B of I. So whatever B of whatever B array you have, right, for all those B arrays, whatever indexes you have, you will take them from the array, original ARR array, and take their sum, and that is how you're going to get this particular value, right? So does this make sense so far, guys? Right, that you have to do what, you have to basically maximize, your task is to find the maximum value of this particular sequence of this much length. Okay, so how can we do it? Okay, so people are saying that because of memoization this does not work. Map, yes, you can use map. Actually, what you can basically do is, now, if you are given such kind of an array, so see, first thing is that if you're given such kind of an array, right, so you can see here, let's say we have been given what, like we have been given n value as 5, and we are given the ARR array as what, let's say we are given the ARR array as 1, then we are given 5. Okay, then after that we are given 3, then we are given 7, and then after that we are given 8. Okay, so initially what you can do is, since you have to find the maximum, so you will initialize it as negative infinity, right? That is one thing that you can directly do. And then, like, if you are given this criteria, what is the criteria? It says that the scenario is something like this, that uh, b of I minus 1, okay, it should be equal to error of b of I minus 1. So if you have to do this particular thing here, right, suppose that you have got an array element, right? So if suppose that you have got an array element, and that element, see, you have got the array element. Okay, so if you have got the array element and you, okay, so if you have got this thing, that the array element at the previous index is equal to this particular b of I minus b of I minus 1. Yeah, so what you can actually do is you can develop a relation here, that if suppose that you have ARR of I, right, if you have the element, and from that element you subtract the index. Okay, what you do is, like, if you, like, see, first there's one more thing that you need to understand, that if suppose that I, like, see, what is the scenario? One of the things that I can always do is, if suppose that things, if you think about the worst case scenario, right? So in the worst case scenario, what can happen with this? In the worst case scenario, if only one element satisfies that criteria, okay, if only one element is satisfying that criteria, understand one thing, that suppose that what happens is, if you only want one element to satisfy that criteria, okay, so suppose that there is only one element, okay, which satisfied this particular given criteria. There is only, if from the original array you only take one ARR element. Okay, so basically if your size of the B array, basically I'm saying that if the B element, if this B array that is there, if the size of this array is equal to 1, okay, if it has got only one element, okay, if it has got only one element, so if it has got, this means that it has got only one index, only one index. So if it has got only one index, guys, right, then what will happen? Then after that, at the end of the day, you have to take the sum of all the ARR of B of I, right? So basically you can say that you will take which particular index, you will take the maximum element of the array for that case. Is that clear? Please write yes or no. Is this part clear? Suppose the B array is of size 1 only. If you take what, because you have to consider this kind of scenario now, if only one, if you are thinking about having only one, if suppose that B array is there, and in this B array you only allow one element, one single element. If you allow only one single element, then what will happen? If you allow only one single element, then you have to take the sum of all the ARR of B of I. So this particular index that you will be choosing, you will choose it in such a way that this sum is maximum. So you'll choose the maximum element of the array. Now please write yes. Is that clear? Is this part clear? Right, guys? Are you getting my point here or not? Please tell me. Yeah, it's this. I understand that it was this relation. I'm sorry. Yeah, I just wrote it incorrectly. If it's like this thing minus ARR of B of I minus 1, right? It's equal to the B of I minus B of I minus 1. Yeah, I do truly understand this. Sorry for writing it wrong. Yeah, I wrote the wrong condition accidentally. Yeah, so basically it's like are you getting my point here? Why I'm saying that, if suppose that B array is only taking one element, then you will choose which element of the array? You will choose the maximum element of the array or not? Please write yes in the chat. Is this part clear or not, guys? Because this is very important. Okay, because you have to think, suppose if things don't work, like see, if only you have in the B array you only have one element. So if you have only got one element inside your B array, then you will choose which kind of index? You'll choose that index which is having the maximum value of the, like, this thing. Are you getting my point here, guys? Yes or no? Please tell me. If you choose only one, how many of you are clear with this? Is there anyone who is not clear with this part? Everyone has to tell me, right? So basically what you are doing, understand this fact, what you are doing here is, if you will see, so I have been given what relationship? I have been given this relationship, that ARR of B of I B of I minus ARR of B of I minus 1, it should be equal to what, guys? It should be equal to B of I minus B of I minus 1. I guess this is the relationship that is given. Let me just cross check. So yeah, it says that ARR of B of I minus ARR of B of I minus 1 should be equal to this. So what can I do here, right? So I can basically say here that instead of this, what I can think about is, if I think about this relation like this, B of I, right? So you can do what? You can just do one thing, that take B of I on this side, okay, and then bring this equation on this side. So then what will happen here is, if you will change this thing, okay, so you, like, what I'm doing is I'm changing the order of this equation. Like, I'm changing the elements, like I'm shifting some elements on the left side and one element on the right side. If I'll do that, then it will be like ARR of B of I minus B of I is equal to what? Is equal to ARR of B of I minus 1 minus B of I minus 1. Is that clear to everyone or not, guys? Please let me know. Right, have I written it correctly? Please write yes or no. What I've done is, initially I was given that ARR of B of I minus 1 minus ARR of B of I minus 1 should be equal to B of I minus B of I minus 1. So B of I means B element at the index I. Okay, so if you will see this, so I can rewrite it as what? I can bring B of I on the left side and ARR of B of I minus 1 on the right side. Then the equation will be ARR B of I minus B of I is equal to ARR B of I minus 1 minus B of I minus 1. Okay, then you can develop a relation. Now what is the relation here? So if you will see, you can say that this kind of equation is what, or this equation is what? It is basically the array element, like array at a particular index minus the index. Can I say this or not? Can I rewrite this and this as this? Yes or no, guys? Tell me, please. Right. So you want to find, like, ultimately what you are doing here. This is a very easy question now, because ultimately now you have reduced this equation to basically saying that whatever array index you, like, whatever index you are at, that element at that index minus the index. That is what you have in this equation now, and you have this thing equal to this. So array at the index minus the index is equal to array at the other index minus the index. So you have to do what? If inside a map, if you use a map, okay, and you store all the array of index minus the index, right? So whatever values are same, so you will keep, like, you will take the sum of all those elements ultimately. I'll explain this further, but are you clear with this part? Please write yes. Crystal clear in the chat is what you should write. this question was not about solving too much or thinking about dp this that whatever you were saying in the chat, guys. It was more about simplifying your equation, that if you have got this equation, then you bring it on the left side. So it's basically array element at an index minus index is equal to array element at another index minus index, right? So basically those sums should be equal. Please write clear in the chat and hit the like button for this. Is this part clear? I hope that this part is crystal clear. This was a basic observation that was required. So please write yes or no in the chat if you are able to understand this or not. What I've done is only I have simplified the way the equation is written. Okay, only I've simplified the way the equation is written. Again, I'm saying this. Okay, again I'll write this if you want. It says, see, what did it say initially? It said that a of I minus this thing minus a of b of I minus 1 should be equal to what? Should be equal to b of I minus b of I minus 1. That is what they said. Let me cross check. So it said that this thing, yeah. Okay. So if you will see here, I'll bring this guy on this side and I'll bring this guy on this side. Then what will happen? You can rewrite the equation as what, guys? You can rewrite the equation as a of b of I minus b of I is equivalent to nothing but a of b of I minus 1 minus b of I minus 1. So if you simplify this, ultimately, this is what? Okay, or this is what? It is nothing but, you can say, I'll just do one thing. Okay, this and this is what? Basically, it is nothing but array element at a particular index, right, minus the index. Okay, so what you have to do is all the elements, like you have to do what? You have to find, like, basically you can store this. This is the key that you can store. Basically, this simplifies your equation. So what the question is asking is, you have to find, that kind of a key which is basically array index minus the index. Okay, and you have to return that answer which is having the maximum value. Is that clear? So okay, so basically what is this part clear? GFG questions are now on fire. GFG questions are on fire. Okay, why? Yeah, everyone can hit the like button, guys, please, if you understood this. Now this is like, if you understood this, so for the sake of this question, hit the like button and then we'll proceed further. Okay, so yeah, what you can do now is, now, so basically, see, one more thing that I had initially told, that if you take, see, I'd also told that suppose that if you in the B array you only take one element. Okay, if you only take one element, so if you only take one element, then basically you will have, in the final answer, you have to return the sum of ARR of B of I. So then you will take which kind of element? You will take that element which is the maximum element of the array, no? Maximum element of the ARR array. If you are going to take only one single element, please write +1 if you are clear with this. Are you all clear with this part? That if suppose that the B array only had one single element, then you will then in that case, which kind of index you would like to take? You would like to take that index which has the maximum ARR value, right? Yes or no, guys? Please tell me. This is very simple. This is one thing. Otherwise, what you will do is, otherwise you will iterate and you will store what? You will take a map for yourself. Okay, you will take a map for yourself, and what you will do is, you will do a of I minus I plus is equal to a of I. Okay, why you will do this thing? Why you are going to do this? Because basically, if you will observe, right, so you have to find, like, see, you have to club all the elements which have this value as equal. Okay, you have to, like, all the elements which have this particular value, you have to consider that those kind of elements. Okay, and if so, you have to choose all the kind of elements which have this value as the same. Okay, so if you use a map, so which like, if you use a map, so map will help you to collect that thing, and ultimately out of all these subsequent pairs that you're going to choose, a of I minus I, you have to basically take that one which is having the maximum value of the elements. So that is why, with respect to the with respect to the element minus the element at that index minus the index, you have to find the sum of all the elements now, and you will, at the end of the day, you will take that which is having the maximum. Is that clear, guys, or not? Should I explain more, or are you all clear with this part? Should I explain a bit more, or everyone is clear with this? Just let me know. If you want, maybe I will see if this is feasible on the second this example. So maybe I can show you this. Okay, so yeah, like, basically I'll try to show this to you, but please take a screenshot or photograph if you want. Okay, for this. Now what I will do is, if you will see here now, so if you will see here, so let's say this is 1. Okay, then this is what? 5, then this is 3, Okay, then this is 7 and this is 8, suppose. Okay, so what you will do here is, if these are the elements that are given to me, right? So what I will do here is, if you will see, so basically array element 0 1 2 3 4, so array element minus the index. So 1 minus 0 is what? 1 minus 0. So 1 minus 0 is basically 1. Okay, then if you will see, 5 minus 1 is 4. Okay, then 3 minus 2 is how much? 3 minus 2 is 1. Then 7 minus 3 is how much? It is 4. Then 8 minus 4 is how much? 4. Okay, so so basically what I've done is, I have done this thing. Okay, this is a, like a of I, and this is I. So what I've done is, if you will see here, what I've done is, guys, I have stored the difference of a of I minus I, right? So this is the value. So which particular, like if you see, so this is the value that I have, right? So basically, what are the two values that are there? Basically, one of the a of I minus I value is what? 1. Okay, and another is a of I minus 1, sorry, a of I minus I value is 4. Okay, because these are the two different values that are present. Correct. First, your explain question. First, you explain question. Yeah, I have explained the question now. So if you see here, a of I minus I is equal to 1, and another a of I minus I is 4. There are two kind of options that are there. So you can see this and this is same, right? And then that and that. So basically what I'm trying to say is that there are two kinds of pairs. Now if you see the element at this end, like basically here, which element you have with respect to this, you have element as 1. Then with respect to this, you have the element as 5. Then with respect to this, you have the element as 3. Then with respect to 4, you have the element as what? 7. Then with respect to this 4, you have the element as 8. Okay, so basically if you see with respect to the elements which are having the difference of the element a of I minus I as 1, what is the sum of those elements? So it is 4. It is coming out to be 4 here. Okay, and if you see the other way around, so basically this and this, so basically let me just see. Yeah, so if you'll see this and this, so I guess it's gonna be nothing but how much? 5 plus 7 plus 8. Okay, these are the elements which are satisfying this criteria, this and this. Okay, this particular one, and this particular one, right? So then you take the sum is 20. So which one would you take? You would take this one now. Are you clear with this? Please write yes or no. Again, you all can write clear, and then I'll proceed further, guys. Does this make sense? Very easy, simple, sober, straightforward. Just let me know if it makes sense to you. Okay. So yeah, like you can tell me. So you can take a map, and with respect to this thing, you can, with respect to 1, what you will do? You will store the sum of 1 and 3. Okay, then with respect to 4, that is a of I minus I, you will store the sum of all these, and you will iterate in the map, and whichever has the highest value, you will take that. Okay, so either the highest can be this, or you will or it will be the single element if you're taking a single element. Okay, is that clear? Okay, so what you will do here, guys, is basically, now can I start writing the code? So what you will do here, can I say that you will take a map, unordered, ORDERED, unordered map. So first of all, I'll take a map, let's say int comma int. Okay, let's name this as empty here, and then after this, what I'll do is I'll initially declare my maximum element of the array as int min. Okay, so suppose if I'm only taking one b of I, then I need to store that now. So what I'll do is I'll iterate in the array. I start from 0 is less than n, I plus plus, and then what I will do is I'll simply say that maximum is equal to max of mx comma ARR of I. So I'll take the, like if I'm only taking a single element at the end, so in that case I'll like to take the highest element of the array. Okay, and at the same time in my map, what I need to do is I need to store the difference of a of I minus I, right? With respect to this pair, I want to store the sum of the element. Okay, and after this, what I will do is, once this is stored, then I need to do what? Then I need to say that maximum sum I'll initialize at as 0, and then after that I'll iterate throughout the map. So auto, let's say I is to empty, so I'll iterate through all the key value pairs of the map, and what I will do is, if the I dot second, okay, if the I dot second, basically the sum is greater than this thing, the maximum sum that I have stored so far, right? So then I'll do what? Maximum sum would be equal to I dot second. Okay, so I dot second, and then once this is done, right, so this is how I'll be storing it, right? And then at the end of the day, what I'll return is either a single element, that is the maximum of only if I take a single element. So that case will be the maximum element, comma, the maximum sum. Okay, maximum sum is basically the sum of the a of I minus I that I have told here in this dry run. Okay, so it will come out to be 20 here. So with respect to 1, 4 will be stored. With respect to 4, 20 will be stored. So you'll take 20 now. Make sense, guys? Yes or no? Please write yes or no, guys, in the chat. Does this make sense for everybody? Okay, it's running fine on the samples. Now let's try and submit this to check if it gets accepted or not. Okay, it says that my code simply does not work. Is there any mistake? Yeah, okay. Some basically I have not initialized it as int min. No, sorry. If I'm going to take the maximum sum also, so I should initialize it as int min. Sorry. Yeah, that's why it became wrong. Still, it is coming out as wrong. Why? Should I take long here? Maybe that would work. Okay, so what I will do is I'll take the maximum sum as long. So if you want, you can. I guess we are going out of bound here. That like basically out of the range because of if you take a lot of elements in the sum, so maybe the sum might exceed. That should not have happened. So why are we going wrong here? Is there any mistake in this piece of code? Let me just check this part. Same test case where I was stuck. Okay. No worries, we'll see that. Long and then what? Let's say this will be long, long. Let's declare this as long as well. Okay. It's not long, long, it's negative number. Okay, let's see. Okay. The logic is, see, the idea is correct, but it is giving avoid adding negative in the map. Yeah, you are correct. You are correct. Actually, you are correct. Yeah, you are correct. Basically, why do you want to even add negative numbers now? Because if you want the sum, now, yeah, correct. So basically, what I will do is, since I want to add, na, so I'll say that if the AR of I, if it is greater than, yeah, if it is like if the element is greater than equal to 0, then only I will add it. Yeah, if it is a positive number, then only I'll add it. Yeah, that is a good way to deal with this. Otherwise, that is why I'm getting errors, because maybe if there is a negative element, so I'm adding it up as well. I'll tell you what is happening here. Okay, maybe suppose that with like suppose that the AR of I minus I, this value comes out to be 4. Now suppose the difference as 4, for this you have the element 7, then suppose you have the element 10, and then you have another element, let's say as minus 6. Then what I'm doing is I'm doing like basically I'm doing 7 plus 10 minus 6, so it is coming out to be 11. But actually the question is expecting that I should add only 7 and 10, so that is why I'll only add the positive values here. So that is why if the AR of I is greater or equal to 0, then only I should add, or you can say greater than 0. And if you do that, then the question would work fine. So yeah, I just missed this case while I was explaining. Yeah, so let me just compile this again and check if it is working normally or not. Then I'll rectify this. Okay, it says that maximum sum was not declared. Okay, let's try and compile it again. Yeah, sorry, I made a mistake here. Right. Okay, now works fine. Let's try and submit this. Yeah, I knew, I when I saw the constraint, I saw that it will not go out of bound. Yeah, is this now clear? Basically, yeah, you will not add the negative elements now, otherwise your sum might decrease. So as I said, if suppose that you have a pair, like if suppose that a of I minus I value is 4, and for that you have element 7, 10, and minus 6. So you will not consider minus 6. Otherwise the sum would be 11. If you don't consider the negative element, then the sum would be 7 plus 10, that would be 17. So that is better. Clear, guys? You can write yes or no. Please write clear in the chat if you're clear. Yeah, clear. You can hit the like button if you're clear and let me know. Please write clear in the chat, guys. And I will quickly copy this so that I can generate a link. Ganesh says clear. What about others? Yeah. So the guy who was making a similar mistake like me, na. So Ganesh, I hope that you are also clear with the idea, right? So yeah, we missed this part. Like basically, I knew this, but that I should take care. Like this might happen, but I just didn't think about like I just didn't see that the elements can be negative also. Okay. So that is one problem with my approach. Okay. Yeah. So now it makes sense. Everyone is clear so far? You can tell me, guys, and then we can move on to the next problem as well. Okay, Lee is saying yes. What about others? Java code would be same, Daya Shankar. In Java, you just have to declare a hash map, nothing else. If you want a Java code, na, so just give me a second. Like, I guess I have given you the link, na, and you can use some AI tool to convert it. Okay, just paste it in any of the AI tools, and it will convert it into Java. So I hope you can do that. I would not name the platforms, but yeah, you can understand that. Okay, you can use some of the platforms to do so. Okay, just paste the code that I have given, and it will give you the Java code. Make sense? Okay, can we move on to the next question? Please write next in the chat. Can we move on to the third question, guys? Now, can we try and think of moving to the next question or not? Yes, clear. What about others? Others are ready for it. So yeah, geek task. The name of this problem is basically what? The name of this problem is geek tasks. Right now, if you will see this particular problem here, so yeah, I guess people are ready. Okay, so let's continue. If you see here, it says that the geek is given a grid of n rows and m columns, right? So basically it says that there's a geek and he has been given like n rows are there, right, and m columns are there, like this. So basically n rows are there in this grid and m columns are there. Okay, m rows and n columns are there where each cell is initially set to 0. So initially, I guess every cell is having the value as 0. That is what they are trying to say. Okay, so if this grid is there, so every cell is, I guess, having the value as how much? 0. Okay, every cell is having the value as 0, right? Now where each cell is initially set to 0, so every cell is having the value as 0. Time limit for question 3 was too tight. My question got TLE in order of query times. Your question got TLE. Okay, I'll see that. Aditya, I'll see that. Okay. So yeah, if you see here, it says that like then after this, you have been given what? Like after this, the question says that you have been given. It says that you have been given what? The question says that you have been given q task for you, and in the kth task is done as follows, right? So in the kth task is denoted as follows. So in the kth task, what you do is you will be given the bottom right row and the bottom right column. Okay, so basically what will happen in the kth task, let's say in the kth task, what will happen is you will be given a pair. Okay, let's assume that what you're given is if you are given a pair, right? So let's say you are given what? Let's say you are given a pair as a comma b or whatever you are given, right? So basically what you will be given is you are given the bottom right row and the bottom right column. So basically if there's a particular grid, no, if there's a particular grid, then what you're given is maybe you are given some this kind of an index, right? This kind of an index, like this kind of cell index has been given. Let's name this pair as a comma b, whatever. So yeah, basically this location of the cell has been given, I guess, right? So for each task like this, where this is this. Okay, for each task, geek increments the cell I comma j. Okay, so yeah, basically what they are saying is that at that cell the value will get increased, no? Basically for each task, geek increments the cell where, okay, and j is less than equal to this by one. Okay, so basically what you do is you are given this cell. Okay, then after that what you do is all the cells that are going to lie in this region. Okay, I guess what they are going to do is like basically, let's say you're given a pair as a comma b, right? So if you're given this thing, right, so what you will do is now all the cells that lie in this region, you will increase their value by one. Okay, you'll increase their value by one, all the cells in this region, all the cells in this region. Okay, suppose if a guy already has value as 2, then it will become 3, and like that. Is that clear? Please write yes in the chat. Is this part clear? Please write yes. Are you clear with this part, guys? Yes or no? Am I saying this correctly? Have I said this correctly? Yes or no? Right. Understood this part? Right. Guys, let me know. Okay. So yeah, if you see here, so why not order of q? Order of q will be fine, because if you are running it, suppose you were running it in order of q time Aditya, then order of q like is 10 to the power 5, so maybe that would have been fine, right? So yeah, basically it says this. Then after executing all the tasks, return the count of so once you have executed the task, then you have to tell that what is the count of like you have to count of non-zero cells that do not have value equal to the maximum value in the grid. Okay, so guys, understand this thing, that after this is over, right, what you have to do is like see, basically on this basis you have to update the grid. And once the grid is updated after all the queries, so you need to know what was the maximum value. So you have to keep a track of the maximum, guys. Okay, and once you have kept the track of the maximum, right, then after this, from that like whichever cells are not having that value, right, and they are not zero, then you have to return that. Kalyan and double IT is saying that I have to explain again. Which part, Kalyan, you want me to explain again? Can you tell me? You can just tell me and then I would explain again. My time complexity is this much. If your complexity is this much, then it should have worked. This is no q log. Okay, okay. It is q log of q. Q log of q. Okay, so what is q log of q? So let's say 10 to the power 5 into what? Log of 10 to the power 5. What is the value? Ones, tens, hundred, thousand, 10,000. Yeah, so I guess it would have been under control only if you were doing like that. But I guess your complexity is more than that. Yeah, which what you want me to explain again, Kalyan, you can tell me, right? I'm waiting for you only, Kalyan, else I would like to proceed further. People with this much time complexity got AC, but ours got okay. Their code for the same complexity got accepted. Okay. Let me just check this. If that is so, how can I check this? Like, if I click on submissions and all submissions, right? So, let's say if I view the submissions. So, yeah, this guy is doing what? This guy is doing it like this. Yeah, he's kind of doing it in linear fashion. But you're saying people with this much complexity got it accepted, right? So, let me just check. Really? I cannot see anyone sorting it. Let me just check. What I will do is, do we have a filter for this thing? Yes, we do. So yeah, let's just check. Is that true that this much complexity got accepted? Are you sure, guys? Mm, I can't see anywhere anybody sorting this and doing this. Yeah, so this guy has done it in sorting and he got it as accepted, right? So yeah, he has taken this thing, then he is sorting this. Yeah, so he is sorting it, right, and then doing it. So yeah, sorting got accepted. It should get accepted basically, because it will be under the constraint now, because 10 to the power 5 into log of 10 to the power 5 would be under okay only. So that's why it will get accepted only. So yeah, what is the problem then? Yeah, that sort is there. Yeah, sir, go with your explanation. Yeah, that is one thing, but yes, it will get accepted only, na. So you can see this guy has submitted it, and yeah, it is getting accepted because it will get accepted, na. Uh, n log n because if you have q pairs, so q log q will get accepted. So maybe what you might have done, guys, it might not have been that optimal because q log q is getting accepted, na. So in your approach, is there something more? Like you might be applying something more to it. With the time complexity q log q, it is working, but we have to make another vector of pairs similar to task modifying task vector gave TLE, but making other vector got accepted. Yeah, your constant factor might have been high. Yes, sir, it should get AC. My code is getting passed for all the test cases, but I don't know. Okay, no worries. So yeah, basically, any other comments? Anything else? So yeah, let's say once it gets done, right? So then you would just give me a second, guys. Okay, so yeah, let me paste this. So I am just going to save some time, and what the code that I was showing now, I've just copied it on my board here. Okay, so that we can discuss it. It's basically my code is much more cluttery compared to this guy's code. So that's why I'll try to explain his approach. Right? Is that fine? Right, go with your solution, but my code is a bit more cluttery, so I guess this is fine, right? So yeah, basically it says that you have been given this thing, and after executing all the tasks, return the count of the non-zero cells that do not have the values equal to the maximum value of the grid. Okay, so firstly your job is what? Understand this thing, guys, that what is your job, right? So firstly, when you are given the pairs, right? So when you are given the pairs, so what you are given? You are given the bottom cells one by one, right? So like basically, let's say you are given what whatever pairs you are given, right? A comma B pairs, let's say you have been given. Now when you have been given all these pairs now, so if suppose that there is a query, like if suppose that there is an update, what, let's say in this case what you have to do is, if you have to update like this region, right? So you are given this black guy, right? Then after that what you're given is then let's say this guy is there, so this guy tells you to update this much, all of them, right? And then after that there's another guy, let's say I'll change the color and I'll make it green. So let's say this guy is there and this guy is incrementing this much region, right? So this guy is there. So I will do what? First of all, you can store all these pairs, right? And then start from this particular pair. Why you would like to start from that pair? So basically, see, what you basically want to do is you want to find a couple of things for yourself. Now what are those things that you want to find? Firstly, find that what is the least value of that cell, like that bottommost right cell that you are going to update. Okay, so basically what you do is, initially you will initialize your minimum x and minimum y. Then you're going to make a pair, let's say A comma B pairs. And so when you're given these tasks, so you will do what? You will make a pair of A comma B, right? And then after that what you can try to do is, like, try to find the minimum value and the minimum value of the x coordinate and the y coordinate of these. So out of all these, this black one would be satisfying the criteria for the minimum x and the minimum y. So basically, what how that will help? I'll try to make you understand that. But then after this, what you do is you sort the pairs. Okay, sort the pairs in decreasing order. So when you sort the pairs in decreasing order, then you will start with the highest pair, which is like the pair which is having the highest value of which is having the highest value, right? So basically then what will happen is, sorry, if you will sort the pairs, then you will be starting from the lower values only, right? Yeah, so when you will sort in if you sort in the ascending order, then what will happen? Firstly, yeah, I have written it like this, but I am telling you the other way around. So yeah, if you see here, what you will do is, I'll change the color of the pen. So yeah, first of all you will go through this guy and this guy, and you will try to extract some kind of information. What kind of information? So basically, initially you're making your counter as 0, forget about the counter as of now. So you will check how many number of pairs are there, and whatever number of pairs are there, you can iterate. Now while you are iterating, so once you have sorted the pairs in this order, right, then you can iterate like this. Let's say first of all you can go to this guy, then this guy, and then this guy. Okay, so I iterate in the decreasing order only, but you don't need to pass a greater sign here, because since you are having a pair now, so you cannot pass the decreasing, since you are having pq, since the since we are making a pair of vector, right, like we are making a pair, right, we have a list of pairs, so that is why you have to give a custom sort in order to sort. So that is why it in C++ it would be better if you sort in the ascending order only, the pairs sorted in ascending order, and then iterate from the back. This will save you from writing a lot of code. Okay, bro, I did it in m plus q. Yeah, it can be done in m plus q. Sorry, you don't explain the question properly. No, sorting is needed. Yeah, I know that sorting is not needed. I know that, but since many people were saying that they were not able to submit, see, my thing is that this question can be done in sorting as well, and this can be done in linear as well. The thing is that many people have done it in sorting, Harsha. Okay, and still they were not able to get it accepted. So that is why they are having a problem. That if they were able to think in a sorting approach, then why didn't their sorting approach got accepted? So that is why I'm taking some time so that I can explain one of the solutions that is written in the sorting way, so that if there was anything that was missing in their approach, so they can rectify that. Are you getting my point, Harsha? Here, why I am doing this? I could have gone. I could have done it in the other way around. How explain? See video of your former colleagues. Mick Majar Mick. Okay, so basically, see, what you have to do is, like I explained this question, na guys. Are you clear with the question statement or not? Please give me a +1 in the chat. Are you clear with the question statement, or should I explain again? Basically, what you have to do is, you will be given the queries. When you are given the queries, so what you will do with respect to the queries is you will increase, like you will be given the bottommost rightmost cell. So you increase all the values that are lying in those cells, right? I have explained this already, guys, in this part, right? Others are able to understand this, right? If you will see, I had already explained this, that if you are given this cell, this x cell is, let's say, having the coordinates as a comma b, so then this cell and all the cells above it, you will increase their value by 1. That is what the question was saying, right? If you are given another pair, let's say p comma q, right, so then what you have to do is, let's say it is given here, so from here to here, all the cells that are there, you have to increase their value by 1. So that is what the question says, right? And then after that, once that is done, okay, once you have done that, then you have to return the count of the non-zero cells that do not have equal value equal to the maximum value of the grid. Okay, so once you have done this, then what will happen? After you have done the update operations on the grid, then inside the grid, what will happen? There will be a value which will be the maximum value inside the grid. Okay, after you have increased certain cells and all those things, then what will happen? There will be a certain value which will be basically the maximum value of the grid. Okay, so what you have to do is, all the cells that are greater than 0 and that are not having that much value, right, equal to the maximum, you have to basically return the count of them. Is that clear? Please write yes or no. Is that clear or not, guys, till now? +1 in the chat, and that will allow me to proceed further in terms of code. Okay, one of the ways is what? One of the ways is that I can iterate for every query. See, what is a brute force way? The brute force way, even there, Shankar, you are asking now. So the brute force way is that I can iterate through all the pairs of a comma b, right? And then what I can do is, I can iterate I from 0 till a, right, till less than equal to a, and I can iterate j from 0 till less than equal to b, and then I can say that all the elements of those ij's I'll increase by 1. Okay, that is how I can update. If I will do something like this, so it will be order of n cube in nature, because I'm running 3 loops. This loop will take roughly n time, this loop will take roughly n time, this loop will take n time, because I'm iterating through all the pairs that are given to me. So that will be very high, right? So this is not acceptable, because it will give you a TL, right? So if you want it, like, does that make sense now there, Shankar? Things are making sense to you? Because of you, I'm explaining this question part again. Okay, so now if you have to simplify your task, so what you do is, like, you can keep a track of, like, see, when you're given the cells now, so if they have given you this particular grid, okay, so what you do is you will try to do several tasks. What are the several tasks that you will try to do? Try to find that what is the minimum x coordinate that is getting that is getting updated, okay, and the minimum y coordinate, like basically out of all the a comma b pairs that are there, okay, out of all the a comma b pairs that are given, that is the bottommost rightmost bottom right corners that are given to you, right? For all of them, try to find the minimum x, okay, and minimum y. Keep a track of them, okay. Now what will happen is, if you do what, like, also at the same time you keep on storing a comma b. Now sort the pair, okay, just sort the pair normally, like sort the list of pair. Now what will happen, this will sort the list in ascending order. After that, what you do is, you have to iterate through all the pairs. So initially mark your x coordinate as what, x coordinate as initially you can do what, initially keep your x coordinate as nothing but the highest value, and keep your y coordinate as well with the highest value. Now why you are going to do that, I will tell you about that as well. So basically, you have a x coordinate and you have a y coordinate. So initially you keep it with the highest, like with initially x will be there and y will be there, and it will be pointing to the last guy of the list of pairs. Okay, then after that, what you need to do is, inside your counter, like inside your counter, what you will do, guys, like basically which guys will be having the maximum value. So in your counter, if you do x minus p of I dot first into y plus 1, so suppose that if you have got what, it's basically that it the see, I'll tell you what is the thing. The thing is that while you are when you have updated now, so while you have updated that thing, so if you will try to find those updates manually, right, if you will try to check for those updates manually, that is going to take a lot of time. And what is the advantage, can anybody tell me? What is the advantage when the updates are being done? Is there a uniformity in the updates? Am I updating the grid with a particular value? Tell me, guys. I'm always updating the grid with the value as, with the value as what? Can you guys tell me? With the value as how much? With the value as 1. Right. Every time, every cell that is there in my range, it will get updated with the value as 1. No? Are you getting my point? The cells, the update, like the cells that are there, they will get updated with the value as 1. So that is very unique thing, that suppose that if I know that in this particular cell, I have, like, if suppose that I'm in a particular row, I'm just telling you one example, and I know that there are 5 elements that I want to update. So I, like, you can say that all of them will be getting updated by 1. That is very unique thing here. So what you can do is, like, basically, why while you are here, so basically suppose that whatever x was the maximum x that you had, right? Now from that particular x, what you do is you will subtract p of I dot first into y plus 1. Like basically, see, what I'll try to tell you what we are doing here. Suppose that if you had got this thing, okay, so I'll just tell you what is being done here. Suppose that if you had the grid here, okay, then x value would be how much if you sort these pairs. So firstly, I guess 0 comma 3 would be there, and then 2 comma 2 would be there, okay. And in the minimum x coordinate, 0 would be stored, and in the minimum y coordinate, 2 will get stored, okay. Once this is done, right, once you have stored the minimum x and the minimum y coordinate, then after that you will iterate. So first of all, your x will be having the value as 2, and your y will be having the value as 2 as well. Okay, then if you have been given this much grid, right, so yeah, then after this, what you will do is you will iterate, and here if you are initially here, right, so what is the value here? It is whatever is the x, you will subtract the p of I dot first from it, okay. So from your x you subtract this much, okay, because basically if they were saying, see, if you had done what, if previously, suppose that you had a grid, right, and you have this cell as 2 comma 2, let's say this cell is 0 comma 3 somewhere here, okay. So initially you were asked to update how much, initially you were asked to update this much, okay. Then after that you were asked to update like this. Okay, if this was the thing here, so what you will do is, if you're counting, right? So while you're counting, so what are the things that we are trying to count here? Understand? So if you will see, initially the x value was 2. Okay, let me just change the color of the pen. Initially the x value was 2. Okay, so because we are considering this 2 comma 2 cell. Okay, so what he's trying to do here is, if you have got that x, so from that x you subtract this much, into y plus 1 is what you do. So into y plus 1. So basically what you are doing here is, you are taking, if you have a counter, right? So all about cards, copying a making of task, and then using copy is giving TLE. Yeah, will there be a written editorial after this? I don't know. Yes. So basically what will happen here is, if you have got this thing, right? So you can understand one thing, that whatever is the like as of now, whatever is the x coordinate that you have, from that x coordinate, if you subtract the ith x coordinate and then you multiply it with y plus 1, okay, and you keep a track of the maximum y as well, okay, and then at the end, whatever is the x and y, you will have it. Okay, so that will be, then you will add this, that these are the number of people that are there, and from that you will subtract those people which are at least getting one update each, right? At least getting one update each. So which are having the value as that much. Okay. So you are increasing your count with that many values, right? So whichever values are there, which will get updated. Okay. So yeah, basically what this guy is doing at the end, he's subtracting what? He's subtracting all the cells which will get only, let's say, one update. So minimum from that he's subtracting, because all those cells will not get multiple updates, right? Okay, and he is counting all those cells in some way that are getting this thing possible. Okay, so it is marking the includes which are not overlapped. Yeah, it is marking the includes which are not overlapped. I understand that. So I guess what this guy like what he is, what this code is like what this person has written is, obviously I'm explaining his code. Then I'll explain the other one, order of n plus q also. So yeah, sorry, n plus m also, right? So yeah, if you will see here, so what you do is, you will try to count all the values that do not overlap. It's marking it is the marking which includes which are not overlapping. Yes, so basically the ones that are not overlapping. So in the first phase what will happen is, your x value is 2, so 2 minus 0 when you will do, and then you will multiply it with y, so it will be basically 2, because if you have this cell as 0, let's say this is 1 and this is 2, then this is what, 0, let's say 1, then 2, and then this would be 3. Okay, so if this it is like this, then you can say that these cells, like if you do what, if you have this current cell x, like if you have your x cell, like current like x minus 0, if you are doing, right? So this gives me what, 2. 2 into 2 would be 4. So basically all these cells that are there, this cell, this cell, this cell, and this cell. Okay, so inside your counter you will say that these cells, like for these cells, you are counting these cells. Why you are counting these cells? Because these cells will have a higher value, right? So you count these cells. Now after that, so I'll do one thing, like let's say this becomes 4. Then after that what you do is, you will once that is done, so you will keep a track of that. So you will keep a track of these kind of cells that do not overlap with the next interval. Okay, with the next interval, once you, because these will get highest updates now. These cells are the ones that are going to get the maximum number of updates. And like after that, as you keep on going, so you will keep on storing like you will keep on updating your x and y as well. So at the end of the day what will happen, your x would be 0 and y is 3. So if you will see here, what we are trying to do is, like you will try to keep on updating. So when you try to keep on updating here, then lastly x value will be what, Lastly, the x value would be 0 and the y value will be how much? Y value would be equal to 3. So when the x value is 0 and y value is equal to 3, so lastly, for the last interval, there is nothing overlapping. So then you will add 0 basically to your answer overall. So you can see that there are 4 cells that are getting overlapped. So ultimately, the count will store what? The count will store that how many cells were there that were getting a total update. Okay. Then from that, what you will do is, then from that particular counter, you are going to subtract the minimum x comma the minimum y. So then what will happen is those cells only got updated only one time. So basically what you will do is minimum x is what? 0 and minimum y is 2. So basically these are the coordinates. So you can say this is 1, this is 3. Okay, because you will imagine in those terms. So 3 cells are there. So minus 3 when you will do, right, minus 3. So 1 minus 3 when you will do, so sorry, 4 minus 3 when you will do, so it will give you 1. So there is only this one cell that is there, that is not getting updated. Other than that, all of them are. So are you clear with this idea, guys? Yeah, they explain the question first in running this. Yes, so his idea is count all the cells with positive minus count all the cells with maximum value. Basically, yeah, basically what, yes, that is what I'm trying, like basically what I'm trying to say is a similar way, that like whatever is overlapping, whatever is getting, whatever values are getting updated, ultimately you have to do this only, that whatever cells are having maximum value. So how you can keep a track of them? So individually you are keeping a track of all those cells, and then after that you subtract, you are subtracting from the minimum x coordinate comma minimum y. So ultimately finally you are subtracting with all of them. Yeah, so if you will see here, so the count was how much? Yeah, it was 4 here. Okay, then 1. So you can see here count came out to be 4 here, and then you subtracted what? You subtracted not 1, basically 3, so it came out to be 1. There was one cell only that was there, no? So yeah, basically what you do is you are having this value. So yes, if you will see total, how many values are there? This many. So just a second. How should I say this? If you have got this and this, so this, and this, and then what? 3 values here, and then okay, 2 comma 2 till 2 comma 2. So 1 comma 1, 2 comma 2. So all those values will get updated, and then after that, this is the only value that is not getting updated again. No? So yeah, you subtract it from there. Let's say what I'll do is I'll try to explain my approach to you. Basically, guys, the simpler way of doing this could be, suppose that if you have got this thing, right, I'll reset this one and then I'll try to explain. Let's say what you will do here is you will take your long total initially as 0, right? Initially you keep your total value as 0. Then after this, what you can do is, let's say you can take some values here. So let's say long int. Okay, now I have to keep a track of the minimum, let's say x comma the minimum y. Okay, that is one thing that I need. And let me take a variable x and y as well. Okay, now if I have to iterate, so what I will do is I'll say that int, I'll start from 0, I is lesser than q. Then what I will do is q queries are given to me now, and then I'll do I plus plus. So we'll iterate through all of them. Okay, and let's say the x is what, tasks of I 0. Okay, then after this what you have is, let's say y is equal to what, tasks of I 1. Okay, then after this once you have stored the x and the y, so since they are given in 0 based index now, so what I will do is I'll try to increase them by 1. Why I'm increasing them by 1? So that I can I don't have to later on I don't have to worry about the other scenario. So basically I'm trying to think about the grid as 1 based index, so that will be better for us to solve. Now if you're coming for the first time, suppose the I value was 0. So if you come to the first pair, so let's say in fact you don't even need to do this. If I am storing my minimum, so initially I will mark my minimum as what, int max na here, and here also I can mark my minimum as what, int max, let's say. Okay, so what I'm doing here is, first of all, I'm storing the minimum x and the I'll keep a track of the minimum x and the minimum y. Okay, so you can say that the minimum x coordinate will be what? It will be the minimum of minimum x comma the current x that I am at. Okay, current bottom of cell. Then again you can say that the minimum y will be what, as we were doing earlier also. So it will be nothing but the minimum of the minimum y comma the y coordinate. Okay, now once you have got this particular thing, so what you can have is, you can declare vector int, and let's say, like, you can keep a track of the changes in, like, let's say in terms of columns. So initially, let's say if there is a column, right? So suppose that you have got rows and columns, right? So if you have got this thing, suppose that you have, like, see, what I will do is, let's say I'll take a vector v, let's not name it like that. So let's say I'll take a vector v. Now initially I'll mark all the values of that cell as 0. Okay, and I'm declaring it for n size. Now after that, what you do is, like, again iterate. So let's say what I can do is, I can iterate like this. So I'll iterate through all the tasks that have been given to me, right? And let's say for the sake of calculations, I'll do it like this. So basically, let's say the x coordinate will be what? Like, first of all, what I've done is, I have stored the minimum x and the minimum y. Why? Because you need to store that. You need to store that which cell is there that is kind of getting like updated the least, right? Basically, the you are trying to do what? If there are a lot of updates, right? So the one that is getting the update most number of times, because this cell will overlap a lot, no, with that region. So yeah, if you have this x as 0, and then yeah, so then after this, wherever you are at, so in that cell you keep a track of the y. So take the y coordinate and add 1 to it. Okay, because I0 will indicate what? I0 will indicate, let's say if you had x, so if you were iterating, right, and while you were so let's name this as some other variable, otherwise this will confuse you. So basically what you are doing is, like, iterate, like, for all the tasks that have been given to you, right? For all the tasks that have been given to you, iterate through all the tasks, guys, right? And once you are iterating, just it should, yeah, what are people saying here? There, Shankar, let me just do one thing. Mm, okay. So yes, if you will see here, yeah. So what you can do here is, basically have your like, declare a vector v of n comma 0, right? So basically, first of all, declare a vector v of n size with 0, and then what you do is, declare your task, and then long p is equal to uh, I x coordinate plus 1, like, sorry, y coordinate plus 1. Now after that, like, keep a track. Like, what you can do here is, let's say for that vector, let's say as I of 1. So let's do one thing. Let's store it in terms of pair once again, or should I do it above only? That would have been a little better. I think I can do it together with this part only. Yeah, so what I will do here is, I'll do something like this. So yes, what you will do here is, you'll declare n comma 0 here, and then what you will do is v of uh, x coordinate that you have, right? So whatever x coordinate that you have, for every it's like kind of, for every row that you are at now, like, store, like, whatever row you are at, store the maximum of that particular row, that is the v of x. If you are at a v of x, right, so store the maximum of the y coordinate comma the v of x. I'll tell you what this will do. Okay, so yeah, v of x. So sorry, x, basically it should be x. Now what does this mean here? If you have got this thing, right? So initially it would be 0 only. So how this is going to work? If it is going to be 0, then it would not be able to work. Okay, then I'll get stuck. Okay, so I need to think again for this part. If you have got x and then you have got y, okay, and then you have got vx and then vy, okay. Right, so let's say I think we'll come back to this question once again because I've already explained n log n. So let's do one thing because my code is getting stuck at some point. So let's just explain the last one also. Like I'll try to explain my approach for a minute. Okay, guys, because I don't want to waste so much time on this. I've already discussed a lot. So let's do one thing. Basically, it's like at the end of the day, what you will do is whichever guys are it's like this, like basically whatever values are there na total, it's like this. Ultimately what you will do is now whatever like whatever guys are getting total updates, right? From the total cells you will try to subtract the ones that are getting the maximum updates, right? Like that have the maximum value, basically maximum value. Okay, so that is what the ultimate approach will be, like the one that we discussed for n log n, that the q log q, that is what it would do. Okay, so yes, let's discuss this question, valid pair of vertices. Okay, so let's do this. So let's see what this question says. It says that you have to consider an undirected tree rooted at node 1. Okay, so it says that first of all you have to consider a undirected tree rooted at the node 1, then comprising of n nodes numbered from 1 to n. Okay, so there are n nodes numbered from 1 to n. Okay, there are n nodes that are numbered from 1 to n. Each node holds an integer value stored in an array called val. So every node that is there holds an integer value stored in array called val. Okay, so for every node you have a value. Okay, additionally we have been given a 2D edges uh, triplet. So triplet list which consists of the node that are there from u to v, and your objective is to determine all the valid pairs of a comma b. Now what is the definition of a pair? So basically if you will see here, so suppose that a comma b is there, and then what you have is you have the weight. So basically a from like there's a connection between a to b, let's just write it like this, yeah, and then the weight between them is w. Okay, that is what has been given to you, and like you have to find all such pairs which are valid, and the definition of a valid pair is if A serves as the ancestor of B, if A is an ancestor of B, and the weighted distance between A and B is not greater than the value stored at the node B. Okay, okay. So yeah, basically if you will see this particular example, so let us say that we have a tree which is like what? Let's say we have a tree where we have got 1 here. Okay, then what we have is between 1 and 2, the weight is how much, guys? The weight is, let's say, 3 here. Okay, then between 1 and 2 the weight is 3, then let's say between 1 to 6, something like this. 1 and I guess u and v are connected here, right? So we additionally have been given this, so undirected edge from u to v. Yeah, so what I will do here is, just a second, I'll remove this. I'll say that this is, guys, having the value as 6, and then you're having what, the weight as 4 here. Okay, then after this the next pair has been given as 1 4, and the weight has been given as how much, 1 4, and the weight has been given as 2 here. Okay, then after that you have got 6 and 5 like this, and the weight for them has been for this has been given as 1 to you. Okay. Then 4 and 3 has been given and the weight is 1. So 4 to 3, there is a arrow, like there's a path, and the weight is basically how much? Weight is 1 here. Okay. So let me write 1 here. Okay. Then, yeah, you have the output, like output is 5. So you have to count the number of pairs that are satisfying the criteria. So if you see here 1 and 6, okay. So what happens for 1 and 6? For 1 and 6, the path sum is 4. So you have to count all the paths, which like all those pairs which such that the weight between them is not greater than the value of the node. Okay. So obviously you can see between 1 and 6, the weight of the path is 4. So that is why this would work. Okay. Then after that, for 1 and 5, the weight is 5, and which is fine. So that is why this also works. Then after that, between 1 and 3, it works because the path length is 3. So that is why this works. Then 1 and 4, the path length is 2. So that is why it works, right? Sorry, 1 and 4. Then after that, what are the other paths? 1, 2, 3, 4 paths I have already considered. Then 4 and 3 also, I can say that will also be an answer. No? Yeah, 4 and 3 and 1 and 3 also will be 4 and 3 will also be considered, and 6 and 5 also. Yeah. So 4 and 3, you can observe what we have been given is we have been given the weight as 1, and then what has been given to you? Like another thing that has been given to you is 6 and 5. For 6 and 5, you have been given like for 6 and 5, the weight length is 5 1. So, but you have this guy as 5, na, the later guy. So that's why this will also be considered. So you are counting this thing. Okay. Hi, everyone. Okay. So yeah, if you will see here, so you have got these things, right? Now, once you have these pairs, right? So how can you simplify your task? Because suppose that if you have got these pairs, right? So yeah, guys, everyone, you can tell me your approach. What was your approach while solving it, guys? During the contest time, you were following a certain approach or something. Just give me a second. Yeah. So how many of you were able to solve it or not solve it? Please quickly tell me, and then we will be starting off, obviously. Just give me a minute. Were you able to solve this one or not? Okay. Yeah, right. So no, this guy says that he was applying DFS approach. You were applying DFS approach, but actually the thing is that see, when it comes to ancestors, so what like which approach comes to your mind when it comes to this particular thing, that is ancestors, right? If you have to like see, you have to quickly check. You have to quickly check for all the ancestors, right? So if you have to see, if you have to quickly check for all the ancestors, right? If you have to quickly check for all the ancestors, so there's one advanced concept that is there. Okay, I'll tell you. That is binary lifting. Okay, because the thing is, see, before everything, okay, is my screen getting shared? No, I think no. Okay, see, basically one advanced concept, can you see my screen now? I hope that yes you can, right? So yeah, basically one advanced concept that is there is binary lifting. Because if there is a particular guy, suppose that there is a particular guy, let's say as B. Okay, so for this guy I want to check ancestor, which is like I want to check all the guys, na, like I want to check like this guy with this, then this guy with this, then this guy with this, right? So I want to check the ancestors at all the different lengths. Okay, so for sir, for every node we check and make path. Yes. So if you will do it manually, right? See, if there is a node here and you have its ancestor is here way above. So for one guy going through all the ancestors, traveling the distance every time will take a lot of time. Okay, so what you can do is you can use the concept of binary lifting. By using the concept of binary lifting, what will happen is you will be able to store the ancestor, like you will be able to do what, you will be able to store the student, what you can say, you will be able to store the child and the ancestors, right? So by doing that, what will happen is your computations will become simpler. So the assumption here is that if you already know about binary lifting, so it will be applied in the second half of of this, right? So when you have a node, right? So for a particular node, you will try to check ancestor one length above, then two length above. In the worst case, what can happen, if you will see here, in the worst case, what can happen, guys, I'll tell you. See, what can happen is basically, you can have an ancestor one length above, right, two length above, and all those things, like all those things, right, one length above, two length above, and like all those things can happen. So for this particular case, when like whenever you have this, so binary lifting does what, it helps you store the ancestors in power. So can I assume that you all know binary lifting? Yes or no? Do you know binary lifting concept or not? Because the fundamental prerequisite for solving this problem is that you should know about binary lifting. If you know about binary lifting, then after binary lifting, like after knowing the concept of binary lifting, you can very easily solve it. So do you guys know binary lifting? For those who are there with us in this chat, they can tell us. First fundamental requirement for this question is that you should be good enough with binary lifting concept. Right. Otherwise, there can be another approach also. Like if you wanted to solve in a simpler fashion, so like maybe you can use binary search also. But if you use binary search, so that would be a bit difficult indeed. Okay, let me think what to do. If you apply, let's say you can see, you can use DFS and then binary search also, but that might give you a TLE for some cases. Okay. Whenever, suppose that whenever you are at a particular node, okay, so for every guy, if I try to find its parent, right, if I am at a guy, right, and what I try to do is, I try to, if I suppose that if I'm at a particular node, as I keep on going down and down, right, so I can try to check it quite easily, but still that would take a bit of length. So just give me a second. What I will do is I'll tell you how to approach it in the simplest way possible. Okay, so yeah, I guess binary lifting would be a bit tough. So what I will do here is, just give me a second, and I have just compiled one thing here so that we can discuss it in a better way. Okay, so yeah, let me share my screen now. So yeah, I have taken one snippet from the chat only. Like what you can do is, see, one of the ways, one of the they can be multiple approaches for solving this problem. First of all, let me clear that. Okay, so one of the ways that I was thinking to solve it, like, and I did it using that way, but it will be very complex, is binary lifting concept. Okay, so you can use binary lifting concept and then try to do it, but this will be very complex. Instead of this, what you can do is you can use the concept of depth first search, okay, plus backtracking, you can say, plus binary search, okay, plus the binary search concept, and this way you can do it. Now if you apply, like, see, for those who don't know binary search, sorry, binary lifting, it will be very difficult to do this question. Why? Because first of all, you should have a clarity on binary lifting, and then you'll be able to do. Why binary lifting? When does binary lifting come to our mind? Whenever we have to talk about ancestors, guys, right? whenever you have to find what you have, whenever you have to find it for the like whenever you have to whenever there is a problem in which you have to do something with respect to ancestors, one level up, two level up, things like that, then bind lifting comes to our mind. But as of now, going with bind lifting is a difficult job because many of you might not be clear with bind lifting. So since we have another alternative, that is you can apply the DFS approach with backtracking, and then binary search you can apply like during, like while you are going in a certain path, no? So in that path I will apply some kind of binary search which will be very fast. Okay. And then like while why I will apply backtracking, because like see, the thing is that why we need to apply depth first search. Okay. So understand this thing, that suppose that there is a tree like this, suppose that there is a tree given to us like this. Okay. So what will happen here is, if I come down a certain path, let's say if I come here, then after that I come here, then I come down here, right? So if I'm here, then I'll search one distance up and all those things, right? One distance, two distance up, and I'll check with respect to my the weight that I have covered, whether it I'm able to satisfy that criteria and all those things. But the other thing that you need to notice here, guys, is that if I'm going through a certain path, so I'll keep on storing all those notes inside. And when I'll go back, so suppose if this was 1, this was 2, this was 3, this was 4, this was 5, this was 6, this was 7, this was 8. So when I'll go down the path, so I'll store 1, 2, 4, and 6 in my path. Okay. Suppose I was at 6, so before it, one level up, like before it, you can see 4 would be there, 2, and then 1 in the list. But when I'm at a particular guy, now, so like after that, when I'll be moving back from this path, so I'll be popping out 4, I'll be popping out 2, like after that from 2, let's say if I go to 5. Okay. Then after that I go to 7. So then after that I go to 7. So when I'm at 7 na, so then one distance up is 5. So that's why I will apply the concept of backtracking here, because I'll be traveling all the parts. Is this idea clear so far? Like, is the basics clear or not for this? For the approach part, are you clear with the basic fundamentals what we are doing? First of all, see, binary search might not be clear why we will be using binary search, but whatever path I'll be traversing now, so I'll keep on storing those nodes one by one. And once I have explored all the paths from that node, then I'll pop it out. Is this part clear to everyone? Again, the assumption is that you might have solved problems like part sum 3, part sum 4. uh, like part sum 3 should have been solved by you, then only you can understand this. Okay. So yeah, thanks a lot, Ashish, right? Okay. So yes, if you will see here, what you can do is, first of all, like you will make you can make an adjacency list for yourself. Okay. So when the, like, see, you have been given the a comma b pairs and you have been given the edges. So first of all, you can do what? Make an adjacency list. Okay. First of all, do what? Make an adjacency list. Okay. Now what you do is basically, first of all, like with like in the adjacency list of I, like what you will do is, you will like, see, if you have got a and b, I'll tell you what you will do here. Just give me a second. What happened? Yeah. So let's say if you had a comma b comma w with you, right? So with respect to a, in the adjacency list of a, you can say that you will store what? You will store b comma w. And in the adjacency list of b, you will store what? You will store C comma W. Okay. Firstly, you will be storing all this relationship. Once you have done that, then you will mark your answer as 0. Now, what is the answer going to do? Answer is ultimately going to count all, what are you going to return? So at the end of the day, your objective is to determine the count of the valid pairs. So all the valid pairs that are there, you have to count them. Okay. Now, what you will do is, first of all, like you will make a temporary vector. Now why this temporary vector? Because as you keep on as you will keep on going down, no? So like as you will keep on going down, so you will take the sum of that particular path, right? Like let's say if you will go down, I'll explain this while I'm explaining the dry run of this. So just give me a second. Let's do one thing. Let's take this diagram that I had shown. Yeah, let's take this diagram and then I'll be able to explain it in a better fashion. Okay, so see, what will happen here is, when you are starting to iterate, so initially what will happen, understand this thing, guys, that your temp would be empty. Okay. And as you keep on storing the sum, now, so when you'll store the sum, so sum will always keep on increasing. Okay. See, there is a problem. I'll tell you one thing. There's a problem that on the internet that is known as path sum 3. Okay. Part sum part 3, solve that problem. In that problem, the concept of backtracking is applied, that when you're going down a path, you will keep on adding the nodes in a list, and when you're going back from that path, then you will keep on removing. So I'm giving you this thing as homework. If you do this, then things will make more sense in terms why we use backtracking in trees, also how we use backtracking in trees. So here, since we have to talk about sum, so that is why in our temp we will be trying to store the sum. Okay, now what I will do is, initially I'll start from the node 1. Okay, initially what we are going to do is, we are going to start from the node 1. Okay, so what you do is, initially you start from the first node, the very first node that is there, and initially you start from this node. Okay, and initially what is the parent of 1? So for, like, see, in your DFS, what you're going to do is, you're going to pass several things every time we do this, right? You're going to pass the current node that you are at, then you will pass the parent also, and whatever sum you have generated so far now, so you will pass that also. And then apart from this, you can pass your answer and your adjacency list and other things like that. Okay, other things like this, right? Now, what you like, value array also, because you want to access the value of a certain element as well. Okay, so what you will do is, while you will iterate, okay, while you will iterate, so when you are iterating through a particular node, so suppose that if I am like, whenever I am at a particular node, so suppose that if I'll be at 1, so whenever I'll be at 1, then I will try to like, so suppose that if I'm at 1, so inside my answer, if I'm at 1, so okay, so yeah, suppose that, like, what I will do is, if I'm at 1, and then from 1, let's try and consider this particular path, that will be better. Okay, let's try and see that if the diagram was like this. Okay, suppose that if you had got 1, okay, then from 1, where you go, like, suppose that from 1, like, suppose that you are at 1. Now for 1, you will run for all of its children. Okay, so for 1, you will try to run for its children, which okay, so if you suppose try to run for 4, then firstly you will call where, you will call for 4. Okay, from 1, first of all, you will go where, guys? First of all, from 1, you will see that 4 is there, so you will call for 4. Okay, so now you will come here and you will say that 4 is your node and its parent is 1, and in your sum you will store 2. Agree with me, guys? That is what you would do. Okay, and inside your this particular variable also, you'll store the sum. So let's say initially your sum was what, let's say it was 0, so you have stored the sum as, let's say, 0 here. Okay, now after this, because initially your sum was 0, right? So you had stored this much. Now you have come to till this much particular node. Okay, now when you are at this node, right? So when you are at the node 4, so you will try to search, like, what are you going to try and search? So you will try to search inside, when you are at this node, so you'll try to search inside your temporary, inside your so far the sum is how much? So far the sum is 2. So if the sum is 2, so you will try to see that what like, how many nodes are there inside the temporary vector, right? Because if I'm going to store the sums one by one, so this temp will be in increasing order. So this means, if I want, I can apply a bind search cleverly on it. Okay, so, like, let me explain you this way. Suppose that if so far what happened was, suppose that initially you had stored the sum as what, like, first of all, you will be storing the sum as 0, right? I guess, yes. Okay, so firstly you would have stored 0, then you would have stored the sum as 2, right? Then after this, you would have gone down and you would have come here. So when you come here, then the sum is what? Then the sum comes out to be, let's say, if I have to do one thing for change, so let's say I'll change this diagram, and what I will do is, I'll mark this value as something like, let's say, 7. Okay, now what will happen is, when I will come down, right? So while I'm coming down, so sum here is 3. Okay, the node that I'm at is 7. Okay, its parent is what? Its parent is basically 4, right? So now the node that I'm at, currently I'm at this particular node. Okay, currently when I'm at this particular node here, right here. Okay, so what you will try to search inside this particular temporary list, is that, like, you will try to search for the lowest value, that is greater or equal to sum minus the node value, right? So what you will do is, if you have got this, so if you have got, let's say, what, if you have got something like 3 as the sum, right? So 3 minus 7, that is what you will do here. Okay, so when you try to do that, so like basically what you will get, like minus 4. So what is the first index that is having value greater or equal to this thing? So you will get 0, right? So when you get this particular index right here from the array, so you'll get the index as what? Let's say you'll get the index as 0, right? So the moment you get your index as 0, so inside your temp, now what you will do is, if you have got this, so let me just think, how many elements are there that have the sum greater or equal to this thing? So which is the very first index inside this temp array that is having this much sum greater or equal to this thing? So I will be counting this very quickly. So basically, when you are at this particular node, no, so you will be counting all these, like this. There's one node, this guy and this guy. Both will be counted together. Basically, what I'm saying is the pair 4, 7 and 1, 7 will be counted directly with the help of binary search. So basically, when you are at a particular element, so whatever is your sum so far, so the sum was coming out to be 3 here, right? So if you have got the sum minus the value of the node, so node we are passing here, right? So yeah, minus the value of the node, so whatever value of that node is, okay, so you're trying to do a lower bound. So if you try to do a lower bound, so you have got minus 4. So if you try to do a lower bound, you'll get the index as 0. Now what you do is, from 2, okay, from 2 you will subtract this thing. So from 2 subtract what? From 2 subtract the index. So index, which index you got? The first index of the first element, which is having value greater or equal to minus 4. So that index was the index 0, where you had the element 0 only. So you can see the size of the temporary variable is what? 2. So there are two elements in this path. In this particular path, temp dot size will tell me what? Temp dot size will tell me the number of elements in this particular path. Okay, temp dot size is going to tell me about the number of elements in this particular path before the current node that I am at. Okay, from that you subtract the index that you are getting using binary search. This will okay, when you do that, so you will get 2. So this means that this node and this node, there are two nodes that are satisfying the criteria, that are satisfying the condition that if there is a path a comma b, then the weight of all those paths is less than equal to b. So is this part clear now, guys? Question of bind lifting? No, you can, this question is of bind lifting, but you can apply, like you can do what, you can solve it using the bind search approach, like a dfs plus bind search approach. So for every node, whenever you are at a particular node, so you can apply bind search for that path, and then like in the temp, you can store a temporary vector where you can keep on storing the sum one by one till a particular node. Okay, and then you can apply binary search in that particular vector to check how many values are less than equal to that weight indirectly. So that will allow you to count all the nodes directly, instead of for a particular node, instead of counting every pair all the time. Is that clear, Ashish and everyone? Does this make sense, guys? Yes or no? Like, if you want, I'll explain with the help of one more complex example. Okay, so if you are getting an idea, you can tell me, guys. Okay, now suppose that what you had was, if you had 1 here, okay, then what you had was, if you had something like 2 here, then what you had was, you had something like what, let's say something like 3 here. Okay, then you had something like 7 here, guys. Understand this thing? Okay, now suppose what you had was, you had 4 here, then you had got 1 here. Okay, then you had got 1 here. Okay, now if you will see here, what would have happened inside your temp? See what would have happened. Suppose you are at 7. So before this, inside the temp, you would have stored what? You would have stored 0. Then you would have stored which particular element? 0. And then but this will be allowing me to count all the paths. That is something that I don't want now. From 7, every path would be possible. So let's take some other value which will not satisfy this condition. Can I complicate it a bit more such that it can happen? So let's think about a test case. Let's say if I have 1, 2, 3, and then what do I have? Can you suggest any test cases, guys? Let me think about a test case. I'm thinking about a complex test case where things will not work. Okay, so yeah, let's think about such kind of a test case. Let's say what, like I'll think of like I'll tell you about one test case. Suppose that you have this thing, and then again you have one here, and then you have got what, like you have got something like, let's say 4 here. Okay, so yeah, let's say you have got this thing. Okay, so like what will happen, guys? See, okay, 0 will be there, right? Suppose you are at this particular node. So before this sum was 0, then 4, then 5, and then 6. So this is the sum that you have, right? Sorry, you will not be storing this guy, right? Before this, whatever the paths were there, you will store this. So when you come to this guy, then the sum is how much, guys? The sum is coming out to be 6, right? So when the sum comes out to be 6, right, so at this point of time when you come here, so the sum comes out to be 6, right? So when the sum comes out to be 6, then you will try to check sum minus the value. Okay. So yeah, when you are here, so which yeah, when you are here, so the sum comes out to be 6, guys. When the sum comes out to be 6, see, you will understand this now. I have taken a good test case, I guess, right? So when the sum comes out to be 6 here, so you will, when you are at this guy, so 4 is going to make a pair with which element? 4 and 3 will satisfy, sorry, 3 comma 4 pair will satisfy the criteria. Then I guess which will satisfy, 2 comma 4 will also satisfy the criteria now. Right? Is there any other? 1 comma 4 will not satisfy the criteria, I think. No. Okay, so when your sum is 6, so you will try to search 6 minus the value of this particular node. So 6 minus 4, the value comes out to be what? The value comes out to be 2. So which node is there that is having the value, which is the very first index that is having the value greater or equal to 2? Can anybody tell me which is the very first index which is having value greater or equal to 2? Which is the very first index that is having value greater or equal to 2? Please tell me, guys. In this temp array, which is the very first index that is having value greater or equal to 2? Can you comment? Can you comment, guys? In this temporary array, which is the index which is having value greater or equal to 2? Which index? Index 1. Index 1. Please comment 1 in the chat. Index 1. Right? Understood? Yes, index 1. Now when it comes to this, so what you will do is, then if you get this particular index, right? So when you will do what? When you will do this kind of thing, let me change the color. So let's take black color. Yeah. So when you will do what? When you will do temp dot size. So temp dot size means that this guy, temp dot size means that there are 3 people above it. 1, 2, 3. Okay, temp dot size can tells me that this guy 4 can make a pair with 3 other guys, right? So that is what temp dot size will tell me. Okay, and minus when I've done a bind search, that which guys are having value greater or equal to 2, right? Which guys are having value greater or equal to 2, because till this much path the sum was 6. Till this much path the sum was 6, right? So now understand this, like now you will understand it very clearly. Till this much path the sum was coming out to be how much? The total sum came out to be 6. Now if my sum is 4 itself, right, so from the sum that I have, I subtract my value, right? So that comes out to be 2. So basically we can say that all those people who are having so basically it means that I can accommodate all those people which are having distance this much, right? So like I will try to find like those that thing. So basically when I'll search the index, I'll get the index as 1. From this, if you subtract that index 1, so 3 minus 1 is how much? 2. So this tells us that there are two nodes, there are two nodes that are there. Okay, there are total 2 nodes that are there which have which will satisfy this criteria. So that is how this bind search would eventually work for you. Are you getting my point? Please write clear or not clear in the chat. In this DFS code, that is how this bind search will work. And as you keep on moving, so you will keep on storing the nodes, and as you will go back from that path, so you'll remove that particular sum. Because if I was here, then like when I'll go back from this, so I'll remove this particular guy from that, because 5 will be removed from that path. So is that clear now? Please write clear in the chat, guys. I hope that you're clear now. Does this make sense? How you are doing this? This is a very good approach, applying bind search. But yes, you should know lower bound function in C++ and in other languages also similar function would be there. So does this make sense, guys? Yes or no? I have like you can take such similar kind of examples, and then you can see how bind search helps you in this way. So basically this is a concept. I'll suggest that you should solve path sum 3 and some other problems. You should know about binary search lower bound function in your respective languages. So basically you have to find the index of the first element that is greater or equal to the sum minus that value. So basically that will give you the value as 2. So indirectly, if it gives you the value as 2, so you'll find the very first index that is having value greater or equal to 2. So this is the value. So this means that there are 2 people that are there, because basically from here to here the path was 4, here to here the path length is 1, to here the path sum is 2. So basically total 2 elements would be there that will have the value less than equal to 2 paths would be there that will have the value less than equal to 4. So that's how you'll add your answer. Clear, guys? Does that make sense? Okay. I hope that you all are clear. Let me just quickly do one thing. I will now paste this particular code in the IDE and then I'll give it to you. It was a good question, by the way. It was a good question based on my research. Yes, so I'll copy this. Now I will paste it here. Okay. So Ashish says that he has understood this. What about others? Others have understood the approach throughout or not? Okay, everyone is clear throughout. Ashish says yes. What about others? Others can tell me, and if they are clear now, so you can just hit the like button. Sir, for question three, can you raise the issue of TLE in question three? It is a genuine issue. Even your explanation confirms that my solution is correct. Uh, Priyanshu, what is the issue that like if you are having any issue now? So I'll tell you one thing. Just do one thing. I am giving you one email of mine. Okay, .gfg@gmail.com. Okay, so I'm giving you this email. Whatever exact issue you are having now, send it on me on this email with your code and with the screenshot of the error and explanation. Can you explain n plus m? I guess we are already out of time, Ashish, so I won't be doing that. Okay, because already we are going, we have gone out of time. So yeah, Priyanshu, just do one thing. Just the explains that my solution is correct. So if your approach is n log n only, then send it to me on this email. I'll check it by myself that whether the code's complexity is whatever you're thinking or not. Okay, and then we will do it. I guess the third question was a bit implementation heavy. Obviously, people said that they were getting TLE, so I got indulged in that. But otherwise, I already wanted to explain. Ashish, actually, the thing is, I wanted to explain n plus m only. But the thing is that people said that they were getting TLE in their sorting based approach. So that is why I took one sorting approach and then I was explaining it. So that is why it took some time. And yeah, that is how it is. But yeah, this happens sometimes, right? But the last question, I hope that everyone has understood the intuition. Okay, and whenever you go back from a particular path, so you remove that particular sum, so you pop out. Okay, and why you are applying bind search, I have also explained this by taking a help of a test case, right? Because bind search helps. And why bind search? Because when you store the sums, so sum will always keep on increasing, so the array of temp will be in sorted order always, right? So if there is for one node, so for one node you will roughly take log n time, right? So for n nodes you will take n log n time, right? So that is how you have this approach. Even if you would have applied bind lifting for the last question, that would have also have taken n log n time. So instead of bind lifting, bind search is better. Bind search plus DFS plus backtracking is better. Okay, clear guys? Please write plus one in the chat and good night in the chat for one last time, and then we'll end this session. Okay, but yeah, last question was very good. Okay, so that's it from my side for today, guys. Thanks a lot for tuning in, and keep coding, keep solving the problem of the day, keep solving the weekly contest, and keep upskilling yourself. Okay, in other tech stacks also. Thank you. Good night and take care, guys. Thank you. This is Yash Dwivedi signing off. Thank you, Priyanshu.